Hello friends, I welcome you all to this class. This is mathematics class, and today we are here to consider this example. On this topic we introduced in our previous class, derivative from the first principle. So I've been studying the derivative from the first principle in our previous classes, and today we'll be solving more examples on this topic, and we have the fourth example to consider today. So we are considering the fourth example. They asked us to find the derivative of this function y is equals to x raised to power 3 from the first principle. So you start by writing solution, and after that you write your function f of x. Clearly this is a function of x, right? This is a function of x. So f of x is equals to what? X raised to power 3. That's the function given to you, right? So you now write the definition of the derivative of a function from the first principle. We denote the derivative of the function by what? F prime of x. Of course, this is derivative of the function with respect to x, or you simply say dy dx. So this will be equal to limit as h goes to 0 of f of x plus h minus f of x divided by h. So this is the formula you are going to write for the derivative of a function from the first principle. And you must write this formula, and this is the formula you use to solve it, right? So this will be equal to, you follow the formula, limit as h goes to what? 0 of f of x plus h. So look at the function. Anywhere you put anything you put inside the function, you are going to raise it to power what? 3. This is how your function is. So what's inside the function now is what? X plus what? H. So I'm replacing this x with what is inside the function now. So what's inside the function is what? X plus h. And what's inside the function? I'm replacing x with this thing. And I have to raise it to power what? 3. Raised to power 3. The next is minus f of x. F of x is the original function. So that's minus x raised to power 3, because x raised to power 3 is my original function. By formula, I have divided by what? H. So this will be limit as h goes to 0 of this x raised to x plus h raised to power 3. You are going to expand it. So for easy expansion, you can just do, this is x plus h, x plus h, x plus h, x plus h. You can just expand this two first. Expand this, right? X multiply x will be x squared. X multiply h is xh. Then h multiply x is plus hx. Hx is same as xh. Then h multiply h is h raised to power 2. So I've expanded this. And of course, you can simplify it to be x plus h. Some things, you can add some things. You have x squared. Xh plus xh will give you 2xh. Then plus h squared. So you can expand this one now. X multiply x squared is x raised to power 3. Plus x multiply 2xh is 2x squared h. And x multiply h squared is xh squared. Then you are done with x, right? You now use h. H multiply x squared, you have hx squared. Then h multiply 2xh will be 2xh squared. 2xh squared. Then h multiply h squared will be h raised to power 3. So I will just check whether some things, whether I can simplify some things. We have 2x squared h. We have hx squared. Hx squared is same as x squared h. So we can add some things. So we have x squared, then 2x squared h, and hx squared. They are the same thing. So you can add them to be 3x squared h. Then xh squared and 2xh squared They are the same thing. So you can add them to be 3x h squared. Then plus h raised to power 3, the last one. So this thing now I can transfer it here. So I will now have x squared. Sorry, this will be x raised to power 3. Sorry, x raised to power 3. I have x raised to power 3. That is the first one. Then plus we have 3x squared h plus 3x h squared plus h squared. So I've written them all. That's the expansion for this. Then we have minus x raised to power 3 all divided by h. Then this will be equal to limit as h goes to 0 of, so some things can cancel. X raised to power 3 can cancel x raised to power 3. You'll now be having 3x squared h plus 3x h squared plus h. This is h raised to power 3. H raised to power 3. Then plus h raised to power 3 all divided by what? H. You can see that from the expansion, this is supposed to be h raised to power 3 from our expansion of this. Then this will be, h is common, I can factorize h. So this will be limit as h goes to 0 of, h is common here, I have h open bracket. So if I factorize h up, I will divide everything by h. 3x squared h divided by h, I have 3x squared. Then 3x h squared divided by h, I have 3x h. Then h raised to power 3 divided by h will give me h squared all divided by h. So h can get cancelled. You now have limit as h goes to 0 of 3x squared. We have 3x squared plus 3xh plus h squared. So h is going to 0. So you can evaluate this limit. You replace h anywhere you see it by what? 0. H goes to 0. So I have 3x raised to power 2. Then plus 3x multiply h. H is 0. Plus h squared, that's 0 squared. So this gives you 3x raised to power 2 plus 3x times 0 is 0. 0 squared is 0. So this gives final answer is 3x raised to power 2. This gives the derivative of this function from the first principle. I hope you enjoyed the class. I will see you in our upcoming class. Bye.